An AI's greatest power, its amazing ability to understand our language, is also kind of terrifyingly its biggest security flaw. Let's get straight to the topic. It really all comes down to this one simple idea. The very thing that makes these models so incredibly useful, their eagerness to listen and follow our instructions, can be completely turned against them. An attacker doesn't need to write complex code, they just need to find the right words. So how exactly do they pull this off? Well, it's done through a whole range of what we call prompt-based attacks. And you shouldn't think of these as just one simple trick. It's more like a whole toolkit of clever techniques, all designed to subvert, bypass, or steal information from an AI system using nothing more than carefully crafted text. Okay, first up is jailbreaking. This is the classic attack you might have already heard of. It is all about tricking the AI into breaking its own rules. An attacker will basically disguise a forbidden request. Maybe they'll wrap it up in a really complex story or a hypothetical scenario, all to coax the model into generating content that it's been programmed to avoid. A much more subtle technique is something called prompt injection. So imagine you upload a document for an AI to summarize, right? But hidden deep inside that document is a secret command telling the AI, hey, ignore that original task and instead do this other malicious thing. That's prompt injection. It's like hiding a weapon inside a Trojan horse made entirely of text. Then there's another kind of attack called prompt leakage, which is pretty much digital espionage. The goal here is to trick the AI into revealing its own secrets. We're talking its system prompts, its programming, maybe even confidential data from a previous conversation. It's kind of like persuading a security guard to just hand over the blueprints to the vault they're supposed to be protecting. Now, what's really interesting here is the subtle but absolutely critical difference between two of these methods. On the left, you've got instruction overwriting, which is basically about social engineering the AI. You're convincing it to play a role, like an expert with no restrictions, to get around its safety filters. But on the right, prompt injection is more of a straight-up technical trick, hiding a command where the AI just isn't expecting to find one. So one is persuasion, the other is pure sabotage. Some attacks aren't a single knockout punch. They're more of a patient game. Chained prompting is the perfect example of this. An attacker starts out with totally harmless questions, slowly building rapport and a very, very specific context with the AI. Then, after several interactions, they steer the model towards that final illicit goal, one it would have completely rejected from the start. And the list of threats goes even deeper, which just goes to show how incredibly creative attackers can be. Tool abuse, for instance, is when an attacker tricks an AI into misusing other software it's connected to, like a search engine or a code interpreter. Or data exfiltration, which is all about persuading the model to leak sensitive information it has access to. The attack surface is just huge. So this all leads to the crucial question, how do we fight back? Well, there's no single magic bullet here. Instead, securing an AI requires a multi-layered defense. You have to think of it like building a fortress with several lines of protection. Let's take a look at how that fortress is actually built. These are the fundamentals, the absolute bedrock of AI security. It starts with filtering and sanitizing every single piece of text a user provides. Then, it's about designing your own system prompts to be incredibly clear and really hard to override. You have to create a kind of firewall between your instructions and the user's input, check everything the AI says before it goes out, and, this is key, constantly test your own defenses with simulated attacks. This table connects the dots perfectly. If you're worried about hidden instructions, your first line of defense is aggressive input filtering. If the threat is someone trying to trick your AI's persona, you need stronger, more specific prompt engineering. Worried about prompt leakage? You have to separate your system and user contexts. And if the AI has access to tools, you lock them down with strict access controls. You see, every threat has a countermeasure. But remember, and this is so important, no single defense is enough. A truly robust strategy combines all of these elements. You absolutely need controls on the way in, smart design at the core, checks on the way out, and a constant process of auditing and testing to catch whatever you missed. Each slice of this chart is a critical piece of the puzzle. And here's a key takeaway from all this. You can't just automate your way to safety. Human intelligence is absolutely essential. Activities like red teaming, where experts actively try to break your system, are vital for finding vulnerabilities that automated scanners will just completely miss. And honestly, educating users on safe practices is just as important as building any technical wall. So, this brings us to the reality of AI security. It is not a problem that you solve once. It's a dynamic, continuous cat and mouse game between attackers who are developing new techniques and defenders who are trying to build smarter, more resilient systems. This quote really says it all. AI security isn't a destination, it's a process. The moment you stop updating and reviewing your defenses is the exact moment you become vulnerable. Vigilance is the name of the game, plain and simple. If you look at the evolution of all this, early AI development was all about making the models more powerful, more capable. Today, we're dealing with the consequences, this explosion in sophisticated prompt attacks. And the future? It's pretty much guaranteed to be a constant cycle of innovation on both sides, with new attacks and new defenses emerging all the time. So this leaves us with a final provocative thought. As these AI models become even more powerful and integrated into every part of our lives, who do you think will ultimately have the upper hand in this arms race? The people building the defenses or the people finding clever new ways to deceive?